In today's class and video, we are going to look at how to plot a calibration curve for p-nitrophenol, and this is the nature of graph or calibration curve that we are going to get after plotting the calibration curve for p-nitrophenol. Let's start our introduction by looking at what p-nitrophenol is and its reaction in an acidic medium and also in an alkaline medium. So first of all, this is the molecular structure of p-nitrophenol over here. So and we are saying that p-nitrophenol is a phenolic compound with a nitro group. So this is the nitro group on the opposite side of the benzene rings hydroxyl group, and its other name is 4-nitrophenol or 4-hydroxy nitrobenzene. So in an acidic condition, p-nitrophenol is colorless and dominant below a pH of 5. So in this medium, it is in its non-ionized form. And also in the basic medium, it is yellow and dominant above a pH of 8.0. And in this medium, the p-nitrophenol exists in its ionizable form as p-nitrophenolate, which gives a yellow color and has a maximum absorption at 405 nanometer. And its chemical formula is C6H5NO3. So now let us look at this chemical reaction and use it to explain the behavior of p-nitrophenol in an acidic medium and also in an alkaline medium. So what we are going to do is that we are going to use we are going to hydrolyze an artificial substrate, which is p-nitrophenol phosphate by acid phosphatase in an acidic medium to p-nitrophenol, and after that we will increase the pH of the medium by adding an amount of sodium hydroxide solution to it. So from here we can see that this is our artificial substrate, which is p-nitrophenol phosphate, undergoing hydrolysis or being hydrolyzed by our enzyme acid phosphatase in a pH of 4.8 to p-nitrophenol. And what we also have to note is that in this acidic medium, the p-nitrophenol hydrolyzed from the p-nitrophenol phosphate is colorless, because as said earlier, in an acidic medium, p-nitrophenol is colorless. Now, so if we are to increase the pH of this medium by adding an amount of sodium hydroxide solution to it to cause an increase of the pH above 8.0, the p-nitrophenol which is being produced in an acidic medium now becomes ionized to p-nitrophenolate, and this as a result causes a change in the color of the medium to yellow and has a maximum absorption at 405 nanometer. So now let's look at materials and reagents that are needed to plot this calibration curve. So the first is 60 micromolar p-nitrophenol solution. The second is 0.02 molar sodium hydroxide, and we also have the spectrophotometer of wavelength 405 nanometer. So now let us see the test protocol. So the first step is to set up 6 test tubes containing 0.0, 1.0, 2.0, 3.0, 4.0, and 5.0 mL of 60 micromolar p-nitrophenol solution. So as you can see over here, these are the various test tubes containing the required volume of each of the of 60 micromolar p-nitrophenol. So then the second step is to bring each tube to a total volume of 6 mL by adding an amount of 0.02 molar sodium hydroxide to it, and after that we mix well and read absorbance at 405 nanometer. So now let's do some calculations to determine the moles of p-nitrophenol in each test tube. So we are going to use the equation concentration is given as mole over the volume in dm cube, and we make the moles the subject in this equation. So making the mole the subject, we have mole equals concentration times volume in dm cube, and we know that the concentration of the p-nitrophenol that is being used in this test is 60 micromolar. So the 60 micromolar is going to run through, and the volume is also in dm cube over here. So let's look at some examples. Example tube 1. So volume of p-nitrophenol used is 0.0. So obviously, if you have to substitute this value into the equation, we will get our mole to be 0.00 micromole, because the first tube contains no p-nitrophenol solution. Now, so test tube 2, volume of p-nitrophenol is 1. So if you have to substitute this, and we shouldn't forget we have to convert this into dm cube. So if you have to convert this into dm cube, then 1 over here becomes 1 times 10 to the negative 3. So if you have to calculate this, you get 0.06 micromole. For test tube 3, the volume of p-nitrophenol added is 2 ml. So if you have to substitute it into the equation, we will get 0.12 micromole. For test tube 4, we have volume of p-nitrophenol to be 3, and if you have to substitute it into this equation, we will get 0.18 micromole. For test tube 5, so the volume of p-nitrophenol is 4, and if you have to substitute it into this equation, we get 0.24 micromole. For test tube 6, so we will get 0.30 micromole. So this happens to be the calculated moles of p-nitrophenol in each of the test tube. So now let's look at this assumed table of results after reading our absorbances. Now, so these are the test tubes over here. So we have test tube 1 to test tube 6, and this is the volume of p-nitrophenol in each test tube. So for test tube 1, and obviously it's going to be our blank because it contains 0 ml of the p-nitrophenol. Test tube 2, 1 ml, 3, 2 ml, 4, 3 ml, 5, 4 ml, and test tube 6, 5 ml of the p-nitrophenol. And this is the volume of sodium hydroxide added to each of the test tube to make a final volume of 6 ml. So for test tube 1, we add 6 ml of the sodium hydroxide. Test tube 2, 5 ml. Test tube 3, 4 ml. Test tube 4, 3 ml. Test tube 5, 2 ml. And test tube 6, 1 ml. And these are the absorbances obtained for each of the test sample. So we are going to use test tube 1 as a blank against the rest of the test tubes to obtain their absorbances. And these are also the calculated moles of p-nitrophenol in each test tube. So now let's see how to plot the calibration curve for the p-nitrophenol. Now, so to do this, we plot the absorbance obtained at 405 against the calculated moles of the p-nitrophenol in each test tube. So if you are to plot the absorbance against the moles of p-nitrophenol, this is the nature of graph that we are going to get, and with the line of equation giving us as y equals 6.2976 s plus 0.0955, where the y happens to be the absorbances on the y-axis, the 6.2976 happens to be the gradient or the slope of the graph or of the line, and s happens to be the moles of the p-nitrophenol on the s-axis, and the 0.09555 happens to be the intercept on the y-axis. So this is the nature of graph that we are going to get, and I will also encourage that for a detailed information on how to plot a calibration curve, just watch my video on calibration curve. Thank you.